Hey, welcome back everybody. In section 11-9, we're going to start solving equations with radicals in them. Here. Square root of 5x plus 7 equals 10. Now, in order to solve, we need to get the radical by itself. In order to do that, we need to get rid of the 7. Now we have square root of 5x equals 3. We need to get rid of the radical. We'll square both sides. When we do that, that'll give us 5x. On this side, 3 squared is 9. And then we just divide by 5. Okay, let's try it again. Here. Square root of 3x plus 1 equals square root of 2x plus 3. We need to get rid of the radical. It's already by itself on both sides, so we'll just square. So now we have 3x plus 1 equals 2x plus 3. Okay, now it's just back to solving a regular equation. So subtract 2x on both sides, subtract 1 on both sides, so that's gone and that's gone. X equals 2. Let's try one more. Okay, just like the other two problems, we need to get the radical by itself. We need to get rid of the 5. That's gone. Square root of x minus 2 equals negative 2. We need to get rid of the radical. We'll square both sides. That'll cancel out the radical. X minus 2 equals 4. Yeah, negative 2 times negative 2. Okay, just solve for x. Is this okay? Trick question. Yeah, the calculation was fine. Thing is, with all equations, it needs to work when we put it back into the original equation. Yeah, we should have been checking with the others as well. Yeah, it's this habit we don't normally do because we trust our calculations already. So here, let's replace 6 into the problem. The square root of 6 minus 2, or 4, the square root of 4 is 2. 2 plus 5 is 7. That's a false statement. It doesn't work. This one is actually an empty set. Let's go back to the other two then. Let's replace 2 into those. Square root of 3 times 2 plus 1. Square root of 2 times 2 plus 3. 3 times 2 is 6. 6 plus 1. Square root of 7 equals 2 times 2 is 4 plus 3. Square root of 7. That's a true statement. So again, since we're solving for x, we put it in set notation. There's one solution, 2. We can do this one as well. The equation was radical 5x plus 7 equals 10. The solution we got was 9/5. So 5 times 9/5 plus 7 equals 10. The 5's cancel. So square root of 9 plus 7. That's 3 plus 7, which is 10. Again, we have a true statement. So it is a solution. We write our answer in set notation. If you look at that problem where there was no solution, can you tell the difference between this one and the other two? Right there. Here. Let me write that step so it doesn't have all the extra markings. X minus 2 equals negative 2. Is it a little more obvious now? From our definition, the square root is supposed to be positive. If there had been a negative sign out here, then it would have worked. We have square root equals to a negative, therefore it's already not possible. From here, you can already say it's an empty set. Let's try one more then. Okay, here. 11, sorry, minus radical y minus 3 equals 4. Okay, we need to get the radical by itself. I'll subtract the 11. Negative radical y minus 3 equals negative 7. Okay. There's still negative here. If I divide both sides by negative 1, we have radical y minus 3 equals 7. So we know it's going to work. Yeah, the radical is equal to a positive. We just got to solve. If I square both sides, that gets rid of the radical. Y minus 3 equals 49. Now, just to prove, in case you don't trust my calculation, the square root of 49, which is 7, 11 minus 7 is 4. Yeah, true statement. So, as noted here, the square root was equal to a positive, so we knew it was going to work. We have one solution, 52. Okay, hope to help. We'll see you in the next one.